Okay, so our process is a subarc system. So it's basically using, and Jeff, you can correct us if we got this mixed up a little, um, twin wire system along with tandem system. As you can see on figure A, you got twin wire, which is just two parallel wires sticking out of the same gun, and you got tandem with two different wire systems. On figure B, the front gun is going to be having the twin system followed by two tandem arc system at the back, and the parameters we were given was the tandem system has a 5/64 inch electrode, and we are conducting a 2F, which is a fillet weld, and the size is 3/16. It's not as presented on the figure, so it's going to be a fillet weld. And the wire we are given is EM12K, and the flux is F4982, I believe. And the settings we're welding at is 1150 amps and 25.5 volts. And the trouble, the wire feed speed is 95 inches per minute. Going along with the presentation, I want you guys to kind of focus on figure B and try to recall back to it. It'll help you guys understand what we're talking about more.
So in this slide, this shows our fishbone diagram for our sub-arc process that could possibly create porosity. So we will be discussing in this presentation is each section, and each section is broken up into subsections. So we have process, that creates low voltage, insufficient flux, no heat treat, flux/electrode matching. For environment, we have vibration, draft, humidity, fixture, and shop cleanliness. For material, we have surface contamination, anti-spatter, incorrect wire matching. For equipment, setup, damaged equipment, and faulty storage.
Okay, so one of the major factors that can be responsible for causing porosity in this process is the process itself. Within a complicated process like twin subarc, many things can go wrong. After doing a little bit of research on the materials that are being used, I found that 5/64 EM12K has a recommended welding voltage of 32 to 56, but our procedure only calls for 25.5. So this low voltage can cause the arc to sputter, which can then lead to slag inclusions, which then leads to porosity. Insufficient flux is also a big problem because if you don't have a thick enough coating, then the shielding that it's supposed to supply becomes inadequate. Now atmospheric contamination becomes a big issue, which then can also lead to porosity. Moisture is another big problem when it comes to porosity, and one of the easiest ways to deal with this is by using preheat. However, our procedure doesn't specify whether we use any kind of heat treatment, and since the environment is also unknown, then moisture-induced porosity is very plausible. However, the cause that I think is most likely would be incorrect wire and flux matching. So F4982 flux, according to Lincoln, performs best when coupled with EM12K with hydrogen designation of 8. However, since it's only EM12K that's used without a hydrogen designation, hydrogen can easily find its way into the weld pool and cause porosity from there.
Okay. Environment. Regarding environment, it's kind of a loose thing, and it's gonna affect all the components that's being used for welding. Within the environment, sub causes could include fixturing and vibration. Imagine if the process is being conducted in a close by environment with a stamping press. You're gonna have a lot of vibration that's gonna move the subarc system around, and depending on if you have a loose fixturing or the components are loose, it's gonna shake around a lot. The wire could move up and down, and it could be exposed to the atmosphere. The flux could also dissipate from the pool itself and expose the arc to the atmosphere. Because we're welding on 2F, it's a lot more. It has a lot more kind of a close tolerance compared to if you're welding on a flat position, so that's gonna also factor in. And fixturing could include of the component itself, the material that's being welded on as well. Other causes, sub causes could include external draft, humidity, and stop cleanliness. I'm going to be comparing indoors versus outdoors. The draft that could result indoors could be from, let's say, a fan or something that's blowing onto the weld zones, or a if the subarc system is close by a door, you could have wind blowing in. Compared this to figure B, if you're welding outdoors, the draft is gonna be a lot higher, which could blow on the flux and expose that arc to the air. Or even if you have moderate wind and more granular fluxes, you could have, depending on how dense that flux or the thickness is, you could have wind getting to that arc, and that could lead to porosity. Especially if it's outdoors, humidity could be a big factor. Um, the flux, if you look at the storage of flux or the wire spools, you may have like water or some form of contamination that's collected on the top surface of that flux drum, and when you go weld with it, you may introduce moisture onto that weld, causing porosity. Indoors, you may have same issues with cleanliness. If you are doing this subarc system on a highly automated place, like if you're welding GMAW or flux core close by, you may have soot flying around the air, and you may contaminate that wire again, or the flux if it's not sealed properly, along with the components itself, the joint itself, which could lead to porosity as well.
The next cause of porosity can be material. Oil and other contamination residue on the weldment during the can cause porosity. During the metal making process, most metals, especially steel, are covered in protective coatings during or after production. If these contaminants are welded over, porosity can be caused by hydrogen deposits in the weld. A common contamination residue in companies that use anti-spatter spray is overuse of anti-spatter spray. Before welding, many welders or operators will spray the weldment with anti-spatter spray. However, if too much is sprayed, the liquid can form small puddles in the joint, putting the weld at risk for porosity caused by hydrogen deposits similar to oil and other contaminations. Another cause is incorrect wire or flux use. Using the wrong, if a welder or operator sets up the process with an incorrect wire or flux, this can cause a negative reaction that will produce a weld with porosity throughout it. The wrong flux will create an undesirable atmosphere for the weld arc. A similar reaction will happen if the wrong wire is chosen. Wire or flux that has been contaminated can also cause porosity.
Okay. Another major factor that can result in porosity is the equipment that is being used for the submerged arc welding process, such as the flux coverage, the lack of flux coverage, the faulty set of equipment, the travel speed, the faulty equipment, and improper storage. So one of the examples I found would be the lack of flux coverage. This is where the flux does not have complete coverage over the weld, thus being exposed to the atmospheric contaminations, as we all know. This can be caused by the contaminated flux that has been clogged in the containment of a flux hopper, or can be resulted to the damaged tube that transfers the flux and submerges the weld. A solution that I found for this could be regular maintenance checks, and for the next example I found would be the faulty setup of equipment, which is a very important factor. Having the incorrect parameters set on the equipment can cause many defects within a weld, such as porosity. For example, having the amps or volts too high for the joint, causing an overburning of the wire being used, can lead to lack of weld coverage, and the wire burning at the contact tip can create this porosity. A solution that can be implemented is regular inspections and or follow the procedures so the operator has a better oversight of the whole application that is being done. Excessive travel speed. If you have excessive travel speed, this could be due to faulty equipment or of the operator's doing. This can also lead to porosity. Solution for this problem would be having the proper settings, proper trained operators, and follow the written procedure. Next slide. So when it comes to faulty equipment, an example that I found would be the wire liner. Wire liner is a very important factor. Wire liner could be possibly damaged and is producing inconsistent wire feed speed. This can create porosity. Solution for this could be doing a test run beforehand to make sure your equipment is running properly, and regular maintenance checks. For improper storage, as it was discussed in the process and environment, the flux can be stored or exposed to wet equipment or wet environment. This could be caused by improper maintenance. A solution for this could be
cut up there. Lag.
This can also lead to porosity.
Alright, so just reiterating the points here. For the process, the main focus would be to either change the flux or to change the wires so that they properly match each other and can perform consistently well.
For environment, so certain factors are gonna like cross-reference each other for sure. Environment's kind of gonna be the overhead for the material that you're using, the flux and the electrodes.
Proper care for materials is important. Porosity caused by a material can be solved by proper training of the operators and welders, as well as clear job instructions and clear labeling on all materials.
For equipment, a very important factor that was discussed would be the improper setup of equipment. So it is very important that you have procedures written for your product or application and proper trained operators so they understand and can resolve the problem such as porosity that could possibly occur during this sub-arc process.
If we are doing a question section, we may have question sections.
Anyone have any questions?
That's basically it.
Oh, thanks, guys. The one thing that I thought you had missed, you did cover. You just had it under environment instead of materials, and that was, I was thinking wet flux. One thing you didn't mention that probably wouldn't be used in this case anyways, but it is used in, say, shipyards that do a lot of submerged arc welding, is that you have weldable primers. And,
sorry, Jeff, what was that? Can you say that again?
Oh, just an extended there. For the application you were given, most of your materials are probably going to come in unprimed and be welded that way. In some industries like the shipyards, they actually put weldable primers on basically right when the raw plates come in before it even gets plasma cut, things like that. One thing to be aware of, and this is a general note for the class, this is not an omission by any means for your presentation, it's just a general comment. Weldable primers, because of their name, people often think, oh, well, it's weldable, it's no big deal. But even when used in the appropriate thickness, oftentimes it does lead to porosity. So be aware that if you ever are using a weldable primer, oftentimes it is best suited for like a twin wire process, so that the weld puddle is fluid long enough for the gas bubbles that